Good morning. Hello everyone. Since we discussed about HT metering, so now we will discuss a little bit more detail about HT metering. There is one particular consumer, right? In this case, there is a consumer here, right? And this consumer, they are applying for a connected load of around 185 kVA, okay, kilovolt ampere. We don't say kilowatt, we say kilowatt only if the connected load is less than 50 kilowatt. In that case, we actually normally don't take into account the power factor into consideration, and whatever is the power factor at the consumer end, we don't actually charge or we don't give any penalty. But in case of big industry like your plywood industry, this the iron and cast steel iron industry, all these things, they will be charged on the basis of kVA. That means whether you improve your power factor or not, that is not an issue, or that is not the burden on the utility like us. We will be charging them on the basis of kVA, but then we don't do that to the public consumers of lower loads. All right, so let's say this particular consumer is having a connected load of 185 kVA, and since this connected load is more than 50 kVA, and as per the rule, they don't allow you to take from the public transformer or from the distribution, small distribution transformer. All right, you will have to take separate supply, and that is you will have to take one HT line, either 11 kV or 33 kV. But that also depend on the convenience of the utility or the availability of the line. If 33 is easily available, then you will be given 33, and if 11 is 11 kV and 33. But in for this particular consumer, since 11 is readily available, this is a little difficult because regarding the transformer and also maintenance will be difficult. The voltage is high. All right, so we are giving them this 11 kV. Okay, so let's say this is an industry. Okay, this is an industry, this industry right here. Okay, it may be related with production of plywood or iron or this brick. We don't actually we don't consider much about what you produce, but our only concern is how much load you are taking. Suppose this is taking, like I said, this is a real case. All right, this industry, they have applied, like they said, like they wanted a connected load of 185 kVA. All right, now on the basis of the connected load that we have applied, we told them that you need a transformer, okay, of rating more than 200 kVA, and because of that, they could install they could not use this 200 because it will be too marginal, right? Because 185 is very close to 200, so they cannot use this. Okay, they'll have to use a transformer of capacity slightly higher than this, maybe 20%, or in that case they can use a 250 kVA transformer, or they can use a 300, which is actually not there. So they have installed this 500 kVA transformer, which is fine. There is no issue with this, since they have installed a transformer of almost thrice the capacity of their connected load, or what they actually need, the contract demand, we say. All right, now they have applied for this, since we are giving them 11 kV, and then their connected load is this, then we'll have to calculate, because we'll be doing HT metering, because it will be more accurate. Okay, now 11 kV, then you simply take this connected load of 185 kVA just to calculate the current. Okay, 185 we divide by the 11 kV, how much you are getting? You are getting around 17 ampere. All right, and because of this, your primary current, the city that you will be using will be of a current rating either 20, but in this particular case we have used 25 ampere, which is okay, fine, no issue, because in the future they may increase their connected load, then we don't have to change the combined set. All right, so that is the purpose, and we have chosen this 25 ampere. Okay, and then since our meter that we will be using is of rating 5 ampere, okay, so the ratio that we are going to take is this. Okay, this is the CT ratio, 25 by 5. And in case of the PT, since we are supplying them 11,000 volt, and then the meter will be depending on the meter. Okay, because most of the time meters are of rating 110 volt, so we'll have to step down this to 110 volt. Okay, so our combined set should step down the 11,000 volt voltage to 110 to a measurable voltage of 110 volts. So okay, this is the PT ratio, and then combined together we get the MF. And since we have only this in our measuring system, even the ratio of the meter also is of 1:1, right? So we don't have any factor to be divided in the overall multiplying factor. So our MF will be this only. So 100 how much you're getting? 500. No, 500 is our OMF, overall multiplication factor, is the is the is for this particular measuring system. And then since we have got this, and then metering system will be okay, I'll just like we have this 11 kV line will be 3-phase 3-well. All right, this 11 kV line, and this we will have DO here, DO, and then we will give this to our transformer. Okay, this is 1V 1U 1W. okay, and we will have this is delta connected, and there will be star connected. All right, like this, 2U 2V 2W 2N. all right, like this. So this is what we will be supplying, and the capacity of this transformer, like I said, it depends on the connected load. If connected load, just like in this case, you have used 500 kVA, because they have applied only for 185. Had they applied for 500, then they should have used 750 kVA, depending on the how much they want. So but our rating here should be 11 kV on the HV side and 0.433 kV on the LV side. This is same for all transformers. The only difference is the capacity. You may have 100 kVA if your connected load is below 100, and you may have 200 also. You may have 150, 300, whatever you like to have. So like this, and then the metering system we will install here only. The combined set will be installed here. Okay, and then will be taken to your meter like this. 3-phase 3-wire, 3-phase 3-wire. Then we'll have only like this, PTR phase, Y phase, B phase, like this. So this is the voltage. Okay, 110 volt phase to phase. All right, we will have this. Who is calling? And then this is regarding the PT. We take the PT from all the phases. And then regarding the current, since we are basing our assumption on the fact that in case of HT metering, the current in Y phase will be the algebraic sum. We are taking the assumption that it is a balanced load, right? It's the algebraic sum of R and B phase. So whatever current that flows in R phase and B phase will be equal to that of Y phase. That is algebraic sum. All right, so that's why we are taking only the current in CT ratio of R phase. I mean, CT is there only in R phase and B phase only. All right, so that's why the current that we are going to take will be that of CR phase, Y, and then B, like this. Okay, we are taking current like this only in R phase, in out, and then in Y phase we are taking only PT, and then in B phase again in out. Okay, and then PT is for all. All right, PT is for all, R, Y, B. Okay, so this is a case of metering system. So the only issue here is your your OMF. How much is your OMF here? OMF, overall multiplication factor, is that of PT. This is actually fixed. PT is fixed. We are taking, then we always step down to 110. Okay, this is PT. Into CT, it depends. Okay, if your current is suppose if the current, depending on the connected load that the consumer actually applies, and if for example he applies for 200 or 300, depending on that, and on the basis of that we normally calculate the current. So we base the calculation on the basis of connected load. For example, whatever if your connected load, for example, is 250 kVA, and then we multiply it by 11. If the consumer takes 33 kV, then we multiply by 33. Okay, like this, and then like this. Okay, and then if you're getting like this around 25 ampere, and then we use here, we don't use exactly 25, but we use uh, 40 like that. Okay, 40 by 5, and then this will be 8, and then the multiplication factor becomes 800. Okay, like this. So this is how we calculate the OMF of the HT metering, and this will be same for all. So this much only for today. Thank you.